Hello. As Fernando said, I'm going to talk about some cases, some specific cases of our internal processes. I'm particularly going to talk about an excavation site, as Fernando mentioned, and later I will give you some information about other small tools developed by the company to try and improve life for archaeologists when they use these products. Right, our first case, our first example is for the management of an archaeological site. Fernando may add something later. Right, project description. This project was found in this area and parallel to the road between Levante, Madrid and Castilla-La Mancha, which is sort of a natural route from Valencia to the hinterland to inner Spain. There are many archaeological remains there, many sites as well. We were hired to document existing remains, existing archaeological sites, and any possible discoveries there. We had to, and please correct me if I'm wrong, but during this project, a number of remains, archaeological remains, were found, which gave us a tip, an idea of the potential existence of more remains in the area. These are the structures that were found in the excavation site, 67 silos from the Andalusian period, the Iberian period, prehistorical even, as you can see in the picture, 39 pits and wells of different sizes and shapes, 6 ponds and a number of structures, 2 kilns, round ones, 2 boundary walls, and wall foundations, and 200 rectangular wells, probably used as a way for growing vineyards, vineyard wells. And in the structures, we found different materials such as clay, stone, axes, arrow tips. These are just some examples of the objects found. Now, goals of the project. The goals were very clear: to geometrically document the remains and to document them in an analytic way by means of standardized forms provided by the regional department. But how did we want to fulfill such goals? Well, we first decided to do it traditionally, namely to creating a database, taking orthophotographs with a CAD system, but the application would have been very static. But we wanted to do other things. We wanted to capture the geometry accurately and completely. We also wanted to have a quick and efficient process. In other words, the way of documenting things had to allow field work and to improve the archaeological work. And finally, we wanted it to be versatile. In other words, once everything was documented, the database should allow us to draw sheets, forms, questionnaires, surveys, thematic maps, etc. That's why The technologies we decided to use included GIS, more particularly gvSIG, for a number of reasons. First of all, it already had all the functionalities we wanted, classical GIS functionalities. It could be personalized and we could have access to the code, generate extensions, and then modify the basic applications. And at the same time, we could be backed and supported by a great community of developers with maybe similar applications, or obviously that could be very beneficial, as we could use the code of the community or portions of the code of the community and be helped by the whole developers community to improve our product. And of course, because it is open source GIS, and so we don't have to pay any licenses. Okay, so in the stage previous to the excavation work, the data to be recorded were analyzed, and a data model was designed for implementation on the GIS. We talked to the archaeologists to come up with features, the conditions, and it was quite straightforward a process. This phase included, the model included UA, Unidad de Actuación, an action unit, which shared many homogeneous units. This basic action unit would be given a number of attributes, a 1-1 relationship, and the homogeneous units would be stratigraphic units, UN in Spanish, with structures or strata, including all the filling materials and other fillers in the site. Based on this data model, we wanted to make the excavation work more efficient. We designed a number of preliminary forms or sheets for the archaeologists to start working very quickly and start digging. The a priori units told us where action had to be taken, but they were modified. Photographs were taken as the one you can see, and the initial contour or shape was taken via GPS. With these details, with this data, we went to the office and processed all GPS data using gvSIG. So we were able to generate a layer of polygons and the codes. The goal at this point was to design a preliminary form, so we created a layout with tags, and we saved it on a gvT template in such a way that with the data of the polygons and the templates, we designed a small extension which uploaded all the files, which went through all action units and then generated a form or a sheet. Here it is. The sheet included, on the one hand, the geometry of the action unit with its coordinates, and on the other, the location in the site. Thus, the archaeologist could go on site and find the right spot where he or she was going to dig. This information was given to the archaeologists, and then during the digging, the archaeologists would fill in the form. Well, we could have used questionnaires directly, but a decision was made to 2 minutes to use these forms. So they filled them in, and then we had to document it geometrically. We are a 3D geomatic company. We have our own scanner, so documentation could be faster and more complete. Data were collected a lot more quickly. All 3D geometry was caught, and we also had complete information on the area to be recorded. This is a silo, and with the scanner, with the machine, we could take the whole measurements to then create a cloud with dots from which information could be drawn, information such as 3D models, orthophotos, MDE, section calculation, etc. After completing the geometrical documentation, it had to be entered into the model. Ideally, from the dot cloud, we should have been able to do the introduction into gvSIG, but as Fernando rightly said, this type of insertion cannot be done directly onto gvSIG, so we had to resort to the proprietary software of the scanner to be able to record all the cloud into the model, and then the model was exported and loaded on an open source piece of software which was used to generate models, and based on those models, orthophotographs were generated, which could be passed on to gvSIG. They were transferred onto gvSIG, then digitalized, and finally moved to a database. We chose PostGIS because of its many advantages and because concurrent access was given to enter the data. With regard to alphanumerical information, we had action unit attributes, structures units, and strata units. We used nav table forms with customized forms, thus minimizing errors in data introduction. We had lists, tables that minimized the likelihood of errors when entering all the data into the database. Action unit forms were generated and stratigraphic unit forms were generated. We're running out of time, so I'm going to go very quickly. We improved the extension from the previous phase, and we then generated the sheets for the action units and the stratigraphic units. We also integrated Jasper records into gvSIG, which allowed us to generate customized reports. Other usages, very quickly. Archaeologists always ask us to relate orthophotographs with their planned elevations, and the drawings. So we created an extension by clicking on the points of the drawing. The orthophotograph was opened and linked with the right coordinates, Y, X, Z. I had a video, but I can't play it. In this regard, well, this is another use for an application used for the maintenance of a historical building, for conditioning it. By clicking inside the arch, you gain access to a view inside the arch. As you can see, all the data on all the faces of the arches are interrelated, and by clicking on the stonework you could see the inner face, the inner side of the stones. Sorry, but I think we're running late. Thank you.